All right. Test review number one. Or review for test number one, rather. All right, so let's start knocking these out. If you can pause the video at any time and see if you can answer before me, and then you can check your answer. So if I want interval notation, I know that interval notation is the parentheses or the brackets, or a combination of both. So, number one, -3 is less than, so I know that the less than gets the parenthesis. Less than or equals, the or equals gets the bracket. So this is going to be, so I just grab the endpoints, right? Just grab the numbers. -3, comma 5, parenthesis, bracket. Interval notation. All right, the graph of this guy. So we have our number line. -3, +5. And I want everything in between -3 and 5. Everything in between. So -3 is going to get the open circle, again, because it got the parentheses and the strictly less than. And then the 5 is going to get the closed in circle, because it got the bracket and the less than or equal. And I want everything in the middle. Everything from -3 to 5. All right, number 2. So they give us the interval notation, right? -1 and 3. So those are my endpoints, -1 and 3. So -1 and 3. All right, because it gave me a bracket, this is going to be less than or equals. Again, this bracket is less than or equals. So less than or equals, less than or equals, and X is in the middle. Right? When you have an interval with numbers on the ends, then X is going to be in between those numbers. It's only when you have infinity when things start to look weird. Okay. Let's graph this. Here's my number line. Got the 2 points, -1, 3. And I want everything in the middle. So 1 and 3 get the closed circles because they're both brackets. Right? Because they're brackets, they get the closed circle. And again, everything in the middle. All right. Number 3. Here we have a graph. So we have 2 pieces. So right away, I know that we're going to have a union. Like, we have to have a union because there's 2 pieces. If it was just one solid piece, then we wouldn't need a union. But because there's 2 pieces, we definitely need a union. Not only that, but in our inequality, I know we're going to have or. We're going to have 2 pieces there as well. All right. So in general, negative infinity is always to the left. Positive infinity is always to the right. So one of these, we'll start with the left piece first. So reading from left to right, I want negative infinity, and that always gets, infinity always gets the parentheses, no matter what. And then to -1, and that's going to get a bracket because it's a closed circle up to -1 with the bracket. Union, it's already there. We already kind of pre-filled it in. And then moving to the right, we're going to go with 2, +2, parentheses, because it's an open circle. Not only that, but the open circle kind of looks like a parentheses, doesn't it? So parentheses 2, comma, and infinity. Infinity always gets the parentheses. So infinity always gets the parentheses. So there's the interval notation. Did we have to do the interval notation first? No, we could have started with inequality notation. It really doesn't matter. However, I think doing interval is probably a little bit more user friendly. All right, so let's turn these intervals into inequalities with less thans and greater thans if as necessary. So the first piece, negative infinity to -1. So anytime you have negative infinity or positive infinity for that matter, just replace infinity with x, right? Because infinity says it could be any number way out there, right? Like the largest or smallest number you could think of, and to infinity and beyond, right? So let's just call that x. So instead of infinity, negative infinity, we'll say x. And we want to compare that to the endpoint, -1. Now, x, or negative infinity, is smaller, very smaller than -1. Right? Because x can be -2, -3, -4, ... all the way to negative whatever. Right? So it has to be smaller. And because it's a closed circle, it's or equals. So x is less than or equal to -1. And that should make sense, right? Because the colored line goes less than or equals. And now looking at the right-hand side, 2, how it starts at 2. So x has to be greater than 2, right? Because the arrow goes to the right. X has to be greater than 2. Not greater than or equal because it's an open circle. So just greater than 2. So x greater than 2. Now, if you would have done it the same way, right? Change infinity to x and then compare it to 2. Well, x has to be bigger than 2. Any number bigger than 2. Okay. Number 4. Here we have an interval. So -2, not including -2, up to and including 4. So again, the parentheses here is going to be less than, and the bracket less than or equal. Right? And we want every number in between. That's what that means. So the interval, or the inequality notation rather, it's going to look like x in the middle, the endpoints, -2 and 4, and we just fill in the signs that we already know. Because it's parentheses, I want less than. Because it's a bracket, I want less than or equals. Now, is it always going to be less than or less than or equals? Not necessarily, but typically we write x on the left-hand side and then we compare number to the right. And on an interval from a number to another number, yeah, it's typically going to be either less than or equal. So here's my number line. We'll mark out -2, 4. -2 has a strictly less than, so it's parentheses, and it gets an open circle. 4, less than or equal, bracket, closed circle. And everything in between. Okay. Here we have number 5. X is less than 0. Inequality. X is less than 0. So we want all the numbers less than 0. So all the negative numbers. So 0 is our endpoint. Right, 0 is our endpoint. We let x be infinity. But because it's less than 0, it needs to be negative. So negative infinity on the left. It gets the parentheses. Infinity always gets the parentheses. And 0 gets a parentheses as well because it's strictly less than. This is parentheses. Okay, drawing this out. we'll mark our point 0. And we want everything less than 0 towards negative, right? Because negative infinity is out to the left. So this is going to go this direction. And we get an open circle because it's parentheses, right? 0 got the parentheses, so it's an open circle. Okay. All right. If you were to graph the situations below, which situation would go on the x-axis and which situation would go on the y-axis? Give the independent variable or independent and dependent variable for each situation. So remember, the independent variable does what it wants, and the dependent variable depends on the independent variable. So here we have time of day and the temperature of the pavement of the parking lot. Okay. So I feel like the time of day does what it wants, right? And the temperature will depend on the time of day. You can kind of switch the roles and see if it makes sense. So the temperature can do what it wants, but the temperature will depend on the time of day. That kind of makes sense, but I think the other way is more understandable, right? If we let the time of day equal X and the temperature equal Y. And in general, right, when you have your X and Y graph, X is usually some sort of time, right? Some sort of time, hours, seconds, minutes, and the Y axis is typically, you know, something other than time, right? Money, temperature, distance, things of that nature. So we'll say seconds, hours, minutes. I guess we could have wrote them in ascending order. And then Y is typically like money, distance, and some sort of like maybe speed. Speed is a good one. All right. So independent variable is going to be the time. And then the dependent variable is the temperature. All right, number 7. Your grade, okay, your grade on this test and how long you study for. How long you study. So what's going to depend on what, really? Is your grade going to depend on how long you study? Or how long you study does that depend on your grade? Right? I think it's feasible that your grade is going to depend on how long you study for. So how long you study is independent. And the grade. The grade is dependent. Your grade is dependent on how long you study. So if you ask yourself, right, like which one depends on the other, that's typically how I do that. Okay, for question 8, write the function described. Determine the domain and range. Tell whether the function is discrete or continuous. All right. So the function f of x. So I already see a typo here. The function c of x. Okay, and then here they're saying f of x. So either this is c or that one's f. Either way, it's the function. Right? Either way, it's the function. So let's actually turn this into f. All right, so the function f of x gives the cost of riding the roller coaster 5 times. All right, so f of x is going to be, so 225, that's definitely in our formula because that's one coupon, right? One ticket to ride the roller coaster. So 2.25. Now, you got to remember, it's x. 2.25 times x, right? X being the number of rides. Right? X being, or the number of tickets for riding the roller coaster 5 times. Okay, that's kind of odd. All right, domain and set notation. So curly bracket. Can get a better one, promise. All right, curly bracket. Now, this is saying that you can ride the roller coaster 5 times. So that means you didn't ride it at all, right? 0 times. You just got there. You rode it once. You rode it twice. You rode it 3 times, 4 times. You rode the roller coaster 5 times. Right? You just can't ride it 5 times once. You know what I mean? Like, you had to have rode it once. You had to have rode it twice, 3, 4. But if it's your 5th time, you definitely rode it 4 times before that. And then not riding it at all in the beginning. All right. So the range, right? These are my x's. So the range, it's going to be the output for when I plug in the domain into x, right, into the function. So I spent 0 money when I didn't write it at all. 225 when I wrote it once. 450 when I wrote it twice. 675 when I wrote it 3 times. $9 when I wrote it 4 times, and then $11.25 when I wrote it the 5th time. So we have to plot these points out. Well, I guess we could analyze right now, is this discrete or continuous? Well, it's got to be discrete, right? It's got to be discrete because you can't write it half a time. You can't write it 1 1/3 times, right? 2 3/4 times, right? You can only write in whole numbers. So it has to be discrete. This is going to be dots along the way. It's not continuous because we're not going to connect the dots, because when you connect the dots, you're saying that in between the dots, that makes sense. Well, this doesn't make sense, right? This is the x-axis. This is the y-axis. This is the number of rides or the number of tickets. Y is the money. So you can label this however, right? Like 0, 1, 2, 3, 4, 5, 6, 7. And we can do this. See how many are there? 1, 2, 3, 4, 5, 6, 7. So we can do by 2s. 2, 4, 6, 8, 10, 12, 14. So when I rode 0 times, when I showed up, 0, 0. 1 ticket, 225, a little bit more than 2. 3 is going to be 450. 4. Actually, 2. I'm sorry. 2 is going to be 450. 3 is 675. 4 is 9. And 5 is 1125. All right, and there they are. We're not going to connect the dots because it would make sense, right, for x to be 1/2 or x to be not a whole number. The independent variable, what's on the x-axis? Oh, number of tickets. Dependent variable, the money, is going to depend on the number of tickets. So it's the dependent variable. Oh, you can't see it, but I definitely wrote number of tickets. Number of tickets. All right. So that's number 8. Now, you could have any kind of question similar to this, right? This cost is going to play a role, and typically you're going to multiply that by the number of times something happens, right? Which is typically x. And here they said 5 times. They didn't have to say 5 times. They could have said whatever number. Okay. Number 9. For the following graphs, tell if each is continuous, discrete, or discrete, and give the domain and range in both inequality and interval notation. So there's a lot of things happening here. And then for increasing, decreasing, you can just write it in interval notation. All right. So let's see. First off, continuous or discontinuous? Okay, that's not even what they asked us to find. So continuous or discrete is what they're asking. So I think this is a typo. So we'll call this discontinuous. Discontinuous. So basically, is there a break? If there's no break, if the line keeps going, if the line's connected, it's continuous. If there's any sort of break, then it's discontinuous. So right here, number 9, we definitely have a break. There's an asymptote at x equals 0, right? At x equals 0. Reason being, we'll see this function a little bit later, but the arrows is what implies it. Okay, so here, this is definitely discontinuous because there's a break. All right, the domain, interval domain, so we're talking about all the x's. So imagine there's a little slider, and you have to slide this thing left and right. So what's the smallest, right? Because to the left, or I guess if you look in the camera, to the left is negative infinity, right? Negative infinity is out this way. The numbers get insanely small. So the slider would just keep going on forever. So this is going to be negative infinity to the left, and it always gets the parentheses, right? Your infinity should always be on the ends of the intervals. Infinity should never be in the middle, especially if there's multiple pieces, because there's definitely 2 pieces here. Right now we're focused on the left-hand side. Okay, so the smallest this can be is negative infinity. If I slide this to the right, it'll just keep going and going closer and closer and closer to 0, but it'll never ever actually get to 0. But it'll get as close to 0, infinitely close actually. So we're saying that it can go up to 0, but not be 0. So how do we say not include 0? Parentheses. All right, there's 2 pieces. So union, right? Union. I'll switch colors. Now this right-hand side, it's basically like the left-hand side, except it's on the right. So I know mine, it never crosses the x-axis. So again, if you create a slider and you try to slide this thing left and right, it has to start at 0, right? But not including 0. It'll slide all the way up against 0, but not include 0. And how far right will it go? To infinity. And infinity always gets the brackets. Okay. I want to write this as an inequality. And it's still domain, but now it's inequality. So again, I just replace negative infinity with x. Because it could be any number. In fact, it could be any number less than 0. Now you have to ask yourself, why not less than or equals? Because of the bracket. That's why. Because of the bracket. Or because of the parentheses. I misspoke. Because of the parentheses. So the less than, strictly less than, is because of the parentheses. All right. We say or, because it's a union. And now, so this is where some people, it's technique, right? It's what is your teacher or professor has taught you. So this is saying infinity, right? Infinity is greater than 0. Infinity is bigger than 0. So infinity is greater than 0. So if you replace infinity with x, x is greater than 0. X is greater than 0. So you could either write x on the left or the right. Typically, you write x on the left, and we want x to be greater than 0. Right? Again, greater than because of the parentheses. Right? X is bigger than 0. So that's how you say x is bigger than 0. Okay, switching our train of thought. We want range now. I want range. So range is the y values. So if you create, say, a little slider on the y axis, what's the lowest that the slider can go? And we see that, like right now where I drew the slider, the graph doesn't exist. So it can't be there. So you basically just raise it up. So 0, y equals 0, that is the lowest, the smallest that this can be. And we want a parentheses because the arrows that go out, that go towards the x-axis, never ever cross. So it would never ever be 0. It'll just get infinitely closer. And we slide it up. What's the highest? Well, the arrows that imply positive infinity, and they get the parentheses. Doesn't matter if there's 2 of them. The arrows go that way, so towards positive infinity. Now we write that as an inequality. So inequality. So this is going to be, so remember, we're dealing with y instead of x. So y, we have to compare y to 0. So look, I'm going to write it not backwards, but the other way just to show you. So y has to be bigger than 0, right? If you're comparing 0 to y, well, y has to be bigger. Now, it's not wrong to do this either, but it's a little irrelevant. Like, do you have to put y in between 0 and infinity? No, not necessarily. Like, this is correct, actually. This is correct. But when you start to get nice, right? Like when you're nice, then you know what to leave off, right? We can leave off the less than infinity, but there's nothing wrong with putting it either way. If you want to leave it and make you feel better, that's fine too. Just because you grab the 0 and the infinity and you just put the y in the middle. Again, less than because of the parentheses. Okay. Now we're talking increase intervals for increasing and decreasing. So remember, increasing and decreasing always get parentheses no matter what. No matter what. So for increasing, we always start from left to right. And so coming from the left, coming from negative infinity, if you imagine yourself standing on the graph, walking from left to right, this is definitely an incline, right? You're definitely going uphill. So we're increasing from negative infinity, parentheses, because infinity always gets parentheses, up to 0, not including 0. And besides, decreasing always gets parentheses. All right, for decreasing, it's the same idea. Continuing from left to right, you'd be walking downhill the entire time. Right, from left to right, coming from 0, right, x equals 0, way up here, you'd be coming down. So 0 towards infinity, again, parentheses. Okay, let's see if we can, how many of these we got? We got a couple. All right, number 10. Continuous or discontinuous? Well, I'm looking at the graph and there's no breaks. There's a bend, but there's no breaks. So continuous. There's no holes either. There's no open circles. So continuous. All right, domain. So remember what domain is. It's the x values. There's no arrows, so there's no infinity. No arrows, no infinity. So I'm looking at the x values. So the most left, x, what was that? 2, 3, 4, 5, 6, 7. Negative 7. The most right, x, 7. And they're closed circles. They're closed circles. So brackets. Let's go. All right, writing that as an inequality, I'm just gonna take the end values. The end values. Negative 7 and 7. All right, x goes in the middle, right? Because it's an interval, and we want all the x's in between, negative 7 and 7. Well, because it's brackets, that's too easy. Less than or equal. Less than or equal. Right, they're less than or equal because it's brackets. Right, because of brackets. All right, range. So a completely different train of thought, right? Now we're looking at the y. Now we're looking at the y's. So it's always from bottom to top. So what's the most bottom that this can be? I actually covered it up, but it's negative 6. The least this could be is negative 6. So negative 6 is the bottom. And we're talking y values, right? Y equals negative 6. That's that dotted line right there. And what's the largest this could be? Well, the largest this could be is right here at 1. Okay, because it's closed circles, negative 6 gets a bracket. Okay, at the top, at x equals 0, y equals 1, is it a bracket or parentheses? Well, look, if I erase this where I drew, it's a closed circle. But sometimes the circle isn't always closed. Sometimes it's just a line. Well, the line implies that it's closed, right? As long as there's no, only holes get parentheses other than infinity. So it's basically a bracket. Right, only holes get parentheses and infinity. Infinity gets parentheses. So if there's no arrow, right? There's no hole, so bracket, 100%. All right. Inequality for the range that we just wrote. So inequality for y, right? Because range is y, domain is x. Okay, what I want is to just grab the endpoints, right? Negative 6 and 1. Y is definitely going to go in the middle, right? Y could be any number in between negative 6 and 1. It's brackets. So what's that mean? Less than or equal. Less than or equal. I feel like we're getting somewhere. Okay. Increasing, decreasing. From left to right. From left to right, like reading a book. You're moving from the left to the right. So from the left, we're going uphill, right? This is definitely uphill. So increasing is going to be from the starting point, and it's always in terms of x, right? It's always in terms of x. So it's parentheses, and it's always in terms, like from one x to another x. From one x value to another x value. So we're coming from -7 all the way up to x equals 0. And it's all in parentheses, always. Decreasing is the same thing, except going down, right? From left to right, you're going downhill. Downhill. That's decreasing. So we're starting at 0. Typically, you start where the increasing left off, right? Increasing left off at 0. Therefore, decreasing is going to begin at 0. And we're going to go towards +7, parentheses. All right. Number 11. Okay, immediately it jumps out at you, right? There's two pieces. There's two pieces. It's not continuous because there's two pieces. So discontinuous, right? Make a little note. Two pieces. Two piece. Hopefully I spelled pieces right. Yeah, I did. The other way looks funny. Okay, so interval notation for the domain. So we're talking x's. And it's going to be an interval. Now, right away, there's two pieces because it's discontinuous. So what's that mean? That means, in terms of the interval, we're going to have two pieces union together. So I know that there's going to be a u. There's got to be a u. There's two pieces. Okay, so let's just look at one piece. Starting at the most left, right, and we're talking x's because we're talking domain. So this is going to be -5, comma, -1. Right, -5 is to the left, -1. And it's going to be brackets because it's a closed circle. Bracket because it's a closed circle. So bracket, bracket. Are my unions already there? Because that was the first thing I noticed. Second piece, we're looking at x equals 1. Closed circle, so it's a bracket, right? Closed circle means a bracket. Up to the arrow. Arrow always means infinity. X is going towards infinity. All right. Now writing it at the same interval, same domain, but as an inequality. So the union is going to be an or. We have two pieces. So the left piece, -5 to -1. So -5 less than or equal because of bracket. X less than or equal -1. Okay. Second piece. We're starting at 1. We're going towards infinity, so we can call that x. So we can say less than or equal because it's a bracket. And if you want, you can say less than infinity, but you don't have to. You could have just left it at 1 is less than or equal to x. Something you could write also, x is greater than or equal to 1, which is the exact same thing, right? Because the symbol, the greater than, is going towards the x, right? It's always facing the x because x is greater than 1, right? X is bigger than 1. Okay. Range. Range is the y values. All right, this is where I've seen a lot of people mess this up. So we're on the y-axis, and we say, what's the largest that y can be? It could be 6. +6. All right, my bad. So yes, it is 6, but we always start at the bottom. So we always start at the bottom. What's the smallest that y can be? That's the actual question. What's the smallest that y can be? Well, it's the arrow. So negative infinity. Negative infinity with the parentheses. Going up, the most that this piece can be in terms of y is -1. And it's a closed circle, so bracket. So the smallest it could be, negative infinity. The next highest, -1. Now that's the first piece. So the second piece, we union it with the second piece. So the smallest that the piece on the left could be is 2. Bracket, because it's a closed circle. And then the largest that it could be is 6, which we said in the beginning. And again, that's a bracket. Now notice there's no dot, but there's a line. So a line is just as good as a dot, right? The graph exists. There's definitely no hole. So 2 to 6 with brackets. All right, inequality for the same range. This is going to be, so you could say negative infinity is less than y is less than -1. Matter of fact, less than or equal to -1 because of the bracket, right? Because of the bracket. Again, you don't have to write this part, but if it makes you feel better keeping your thoughts together, then I'm cool with that. All right, or we have a second piece. We want between 2 and 6. So y has to be between 2 and 6. Now, is it less than or equal? It's less than or equal because of the bracket. Less than or equal, less than or equal. Okay. So I'm going to erase because it's going to start to get cluttered. Because we're going to talk about increasing, decreasing. So you have to think about this, right? Increasing is uphill. Increasing is uphill. From left to right, right? It's from left to right. So uphill, from left to right. So we're starting off uphill to the top of the hill. And then downhill. And then even more downhill. Still downhill. So we have 2 downhill parts. And because we're moving from left to right, right? From left to right. We have 2 downhill parts and 1 uphill part. So increasing is going to be from, right? It's always in terms of x, up to some point. So -5 up to -3. -5 to -3. And it always gets parentheses. Downhill, decreasing, are the blue parts. So we have picking up where increasing left off. So -3 up to -1. And then union, because there's a second piece, 1 to infinity. So what am I saying? We're picking up where increasing left off. It's going to end right here at -1. Then it's going to start a new one at +1 and then go towards infinity because it's going towards the arrow, right? The x is. So in interval notation, we have -3 where increasing left off, up to -1, always getting parentheses, union, new piece, 1 to infinity. And everything gets parentheses. Okay. Identify each relation as a function or not a function. Okay. To identify each relation as a function, this is the vertical line test because there's a picture. When there's a picture, vertical line test all day. Because all you got to do is just draw. It doesn't matter where you draw the line, but typically when you're looking, you can see like, hey, there's a part where if I draw a straight line, this graph is going to touch the line in two different spots. Not a function. Right. It failed the vertical line test. It did not pass the vertical line test. Right. For this, we can call this x equals 1.5. Right. When x is equal to 1.5, the y is equal to two different y values. Right. Right here, this is 1.5 comma 2.5, and this is negative 1.5. This is negative 1.5 comma 1, 2, 3, negative 3. So there's two x values going to the same x value, right? Twice going to two different y values, not a function. All right, same reason. We need to draw more vertical. So not. That was 13. So for 14, no matter where I draw my vertical line and I slide it left and right, no matter where I draw it, it only ever touches once. It only ever touches once. So yes. Okay. Number 15. In the set of here, list the inverses. Okay, remember the inverse just switches the x and the y's. So we can say curly bracket, comma 3 comma negative 2, 4 comma 0. Right, because this is my x and this is my y. I'm just reversing the x's and the y's. 1 comma 3, 6 comma negative 2. Parentheses. Or curly brackets, right? It's a set. So is the inverse a function? Well, do the x repeat? That's the question. So here I have 3, 4, 1, and 6. X's don't repeat all day. Yes. X's don't repeat. X's don't repeat. All right. 16. Give the domain. So the x values, talk about x, over which the function is increasing and decreasing. So we're talking increasing and decreasing. So this is just like 9 and 11, but increasing and decreasing only. Increasing, decreasing only. So we know that it's going to be in parentheses. We know it's going to be some x value to another x value. So uphill, right? Increasing is uphill. So right here. So it's starting out at what x value? Negative 5 goes up to negative 2. And it's always in parentheses, right? Always in parentheses. Decreasing, we'll do in blue. So it's going to pick up where uphill left off, right? Because now it reached the apex, like the top, the vertex, and now it's coming down, right? What goes up must come down. So negative 2, it picks up to positive 2. Right, and that's increasing, decreasing. And it's always in terms of x. From left to right. From left to right. You always start from the left and you go right. Okay, 17. Increasing from left to right. From left to right. The only uphill I really see is from the bottom to the top. So this interval right here. Downhill, there's 2. Remember, we're coming from the left, right? From the left. So we're coming down. So this is coming from infinity to the bottom of the hill. Then increasing happens. We get to the top of the hill. and then we decrease again. So, writing this as an interval, the x value where increasing starts is -4. Where increasing ends is -2. And again, it's always parentheses. Can't stress that enough. All right. Decreasing. We're coming from negative infinity. That's where the arrow is coming from, right? We're coming from negative infinity up to the bottom of the hill. So up to -4. Now notice the -4, that's where increasing will start and decreasing stops. So -4, the bottom of the hill. All right, top of the hill, because there's a second piece, we're going to union with at x equals -2, right? So it picks up where increasing stops. All the way to, well, I would say infinity, but that's not infinity because there's no arrow. All the way up to 2, +2. Okay, 18. All right, these dashed lines, we'll talk about these later, but we call these asymptotes. Asymptotes. These are lines that are invisible, that the graph gets close to, but never ever crosses. It's getting infinitely closer, but it'll never ever cross no matter what happens. All right. So increasing, we're talking uphill from left to right. If I'm coming from the left, right, and I'm standing on this thing, if I'm coming from the left, it's always downhill, or it's going downhill. If I'm on the right hand graph coming from the left, I'm still only ever going downhill if I'm walking to the right. Like, you always walk to the right, you never walk to the left. Always walk to the right. So it's increasing never. There is no interval for increasing. Decreasing, however, there is. Matter of fact, there's 2. From negative infinity all the way up to 0, right? Because it never crosses the dashed line. It never crosses the dashed line. And there's 2 of them, right? There's the lower one, then the upper one. So we're going to union. We're going to come from 0. Right, because x equals 0. We're not coming from infinity. Because the infinity in the up direction, that's the y values, basically. We always talk in terms of x. So x, at x equals 0, that's where we're coming from. Because the graph is really close to 0. All right, towards infinity. And is this discrete, continuous, or discontinuous? Well, there's no dots, so it's not discrete. There's 2 pieces, not continuous. Oh, look, it's discontinuous. Because there's 2 pieces, right? 2 pieces. Okay, 19. Let's go. So just quickly looking, there's a dashed line. That implies that the graph will get closer to it, but never ever touch it. So coming from the left, starting on the left, and working our way to the right, it's all uphill. It's constantly uphill. So it's increasing from 0, that's where the x starts, not including 0, towards the arrow, infinity. So increasing from left to right on 0 to infinity on that interval. Where's it downhill? Should be shaking your head. None. There is no downhill in this one. Now you might say, well, wait a minute. It goes down like this. Yeah, but we always go to the right. From left to right, it's always uphill. Right? Like if you live at the bottom of the hill and you look up the hill, leaving your house, it's always uphill. You would never look in terms of coming back, right? Coming the other direction would be down, but always going away, always going to the right is always left to right, always, always. Is it discrete? No, there's no just dots. Is it continuous? Well, yeah, there's just one piece. It's definitely continuous. Is it discontinuous? Or is there more than one piece? No, there's only one piece. This has to be continuous. Has to be. Okay. We're 66% of the way through, I feel. Oh, no. A little bit more than that. A little bit less than that, rather. All right. Find an equation for the inverse relation. All this is saying is find the inverse. Find the inverse. So if you know the process is pretty simple. So it's already in y. So first thing I'm going to do is switch x and y. Swap x with y. Step one. Now, we just isolate y, right? Using basic algebra to undo the equation to get y all by itself. You can't just jump straight at y, right? You got to like handle the things that are around it. Meaning, I have to subtract 5 from both sides first. So, x minus 5 is equal to negative 2y. Then, now y is almost by itself. There's this negative 2 hanging out in front that I got to deal with. So negative 2, divide both sides by negative 2 because that's negative 2 times y. So the way you undo multiplication is division. Cancels on the right. So final answer is going to be y. So y equals x minus 5 over negative 2. And now some would argue that we need an equation, right? So we don't want to just say y because this y could be confused with this y. So what we say is f inverse, right? F inverse of x is equal to x minus 5 all over negative 2. You can get there, like it's golden. Golden. All right, 21. Swapping x and y. All we did was change x and y. And now we get y by itself. So I'm going to add 4. So x plus 4 is equal to y squared. Because cancels on the right? Cancels. Do it in red. Cancels. All right. Next, we got to handle the square. So the way you do the square, take a square root. Now, I have seen people take the square root, leave off the 2, but put the square root. People, the square root and the square, the reason we're doing that is so that they cancel each other out. All that's left on the right is just y. The square root and the square are inverses of each other. They cancel each other out. That's why when I do the square root, I mark out the 2, and then they both disappear. Now, on the right-hand side, right, I can do what I want to an equation as long as I do it to both sides. So I got to put everything on the left under the square root, and I have to say plus or minus. Right? It's 2 answers, positive square root and then the negative version of the square root. So plus or minus the square root, x plus 4. Why is it in blue? X plus 4 equals y. All right. Last step. F inverse of x is equal to plus or minus x plus 4. All I did was change y back to something different, right? F inverse. That's the final step. Number 22. Y equals x. So swapping x with y. Swapping x with y. And now isolating y. So I have to get to the y. So there's a square. So I undo the square by taking the square root of both sides. So I have plus or minus x, y minus 3, right? Because when the square and the square root touch, disappears. It's unlocked. Y minus 3 is now available for me to start manipulating. So I got to add 3 to both sides. So I'm going to get, you can say 3, positive 3, plus or minus, let's do it in blue, positive 3, plus or minus, square root of x is equal to y. Because on the right, 3 and negative 3 cancel. Right? Minus 3, add 3, cancels. All right, y is all by itself. So we're done. We just change y to f inverse. And then make sure to copy the answer correctly. We're not changing the answer anymore. All right, 23. Swap x and y. So equals 3 times y plus 2 squared plus 4. Okay, there's a lot of things attached to the y. What do you do first? Divide by 3, take a square root, minus 4. So what I would do, I would subtract 4 from both sides. Right? I just can't, right? You can't multiply or divide without multiplying or dividing to both terms. So I always try to add and subtract first. So this is going to be x minus 4, 3, y plus 2 squared. Right? Because if I try to divide by 3, I just can't divide the first part by 3. I would have to divide everything by 3. So that's why I didn't do it first. Now that I got the 4 out the way, now I can divide by 3. Right? And then here your options are divide by 3 or take a square root. Well, if I take a square root, notice the 3 is under the square root. So, I mean, who wants to deal with that? It's doable, but, are you nice enough to realize that? So I'm going to divide by 3. Cancels on the right. So we have x minus 4, all divided by 3, is equal to y plus 2 squared. Notice we're slowly chipping away and getting to the y. This is exactly the step that we did here. Right? Undo a square, take a square root. So to undo the square, take a square root. So both sides, the whole thing on the left, all this needs to be under the square root. You just can't do the top. You got to do everything on the left. So we have plus or minus square root x minus 4 all over 3, and that's all inside the square root, equals y plus 2. Notice y plus 2 is in the open. That's what we wanted to happen. So last step to get y by itself, we subtract 2 from both sides. Well, you can't see it, but I'm subtracting 2 from both sides. So this is going to be y is equal to negative 2 plus or minus square root x minus 4 all over 3. And now y is isolated. That's what we wanted to happen. So f inverse of x is equal to negative 2 plus or minus square root x minus 4 all over 3. Not bad, right? I know it happens fast, but we're just adding and subtracting, multiplying, dividing, and squaring. Square rooting. All right, 24. I'm going to swap x and y. All right. Plus 4 is outside of the square root. So now, just like number 23, we can't just handle the y. You got to start furthest away from y and then work your way closer to y. So the furthest thing out is minusing 4. So x minus 4 is equal to 3 square root y minus 2. All right, working closer to y, still furthest out from y, right? Dividing by 3. We're still outside the square root symbol. So x minus 4 divided by 3 is equal to the square root y minus 2. Do you have to rewrite this every time? No, you don't. You could do multiple steps at once if you're nice. Like I'm nice. Like I could do it. But I'm writing out every step so I can show you. Now, to undo a square root, we square everything on the left, everything on the right. What's nice is that on the right-hand side, y minus 2 is just there. It opens up. Left-hand side, x minus 4 all over 3 squared. Second to last step, right? Plus 2, right? Because we're trying to get y by itself. It's not going to move up. So this is going to be y is equal to x minus 4 squared over 3 plus 2. And then to save some space, we're just going to change this to f inverse of x. I'm going to tag over it. F inverse of x. Let's go. You can tell it's late because we're starting to get lazy. Just write over it. You'll be good. All right, 25. Switch x and y. See if you can beat me. Don't mess up. All right. Here I have negative 1 on the right. I want to get rid of the negative. You could either multiply both sides by negative. You could divide by negative. It truly doesn't matter. All right, if I multiply both sides by negative 1. All right, if I multiply both sides by negative 1. So do it like this so you can see it. Negative 1. The negative and negative cancel on the right. And then on the left, we don't never just leave negative 1, right? It's just negative x. Negative x. Square root 3y plus 2. All right. There was a fancier, like, not fancier, but a more efficient way that we could have done this, but maybe you can comment that. So check it out. The negative signs went away on the right. So now, because negative and a negative make a positive. So now to undo the square root, we have to square both sides. And look what happens. On the right-hand side, the square root goes away. 3y plus 2. On the left-hand side, negative x squared. Well, negative x times negative x, because that's what it means to square, right? Negative times a negative is a positive. Anytime you're squaring a negative inside of a parentheses, that negative is going to go away. And then x squared, right? If you're, listening but not listening, where'd the negative sign go just right now? It went away because we're squaring the left-hand side, right? It's all being squared, and a negative squared is just positive. Goes away. minus 2, x squared minus 2 is equal to 3y. Now, 3 times y, that's going to be division by 3. Cancels on the right. Y is all by itself. So let's go. F inverse of x is equal to x squared minus 2 all over 3. Okay. How much more we got? Oh, we're there. We're there. Verify 26. Verify that f and g are inverses. Can use composition method. Okay. Can you? Well, hold on. Can you use composition method? Is this a question? Can I? I feel like I can. So, what this is saying is that if you compose, check it out. If you compose f with g, right? I mean g with f, putting g of x inside of f, and then calculating, right? Simplifying somehow, some way, and that equals x. Then taking g and composing g with f, right? Putting f inside of g basically, and verifying that that comes out to x as well. So when you do both of these methods and x comes out, then they're inverses. But only if x comes out. If something other than x comes out, then this is not at all. They're not inverses, no way, no how. So we'll let f be blue. We'll let g be red. All right, first I want to take g and put it inside of f. Compose it with f, right? So this is going to be 2x, right? X plus 3. 2x plus 3. That's what f is, 2x plus 3. But I don't want f. I mean, I don't want x. I want to substitute g of x into x, right? So I'm putting g of x here. I'm putting g of x here. But what is g of x? G of x is 1/2 x minus 3/2, right? That is what g of x is. So there's the composition. Now we have to start simplifying, right? Start calculating. So the 2 is going to distribute. When the 2 distributes, what's left behind? The 2 is going to cancel with the 1/2, leaving behind x. The 2 is going to basically the 2 is going to clear the fraction, where all the denominators are going to go away. So we're going to get x minus 3 on top. And then plus 3. So notice x minus 3 plus 3, well, that's just x. Okay, so I feel like we're on the right track because we got x to come out. All right, let's try it the other way. So I want g, which is 1/2 x minus 3/2. All right, right, 1/2 x minus 3/2. That's what g of x is. So I'm going to substitute f of x into x. All right, we're putting it into g of x. All right, what is f of x? Hopefully you said 2x plus 3. All right, so now distributing, right, because we've substituted. Now we just simplify and see what happens. All right, this is going to be 2 over 2. So this is just going to be x. And then plus 3 over 2, right? Because 1/2 times 3. 1/2 times 3. So 3 over 2. minus 3 over 2. Oh, this is nice. Because look, x. So they are inverses. We showed it. We proved it. We composed them both directions, and both x came out at the same time. Or x's came out of both each time. So that's what it means to verify. That process right there. Got to be able to do that. Might need to rewind that and watch that a couple times. Okay, so more on composition. So that was when we're composing two functions. Now, graphically, we're going to do the same thing in a sense, but we're going to compose f, g, and h with different x values. All right, so I'm going to use black. So we're going to let x equal 5. All right, so x is equal to 5. There it is. I drew it out. Now, notice there's two graphs. Actually, there's three graphs, f, g, and h. Well, which one do we go towards? Well, we go towards f, right? Because we move from right to left. So I go towards f. I hit f at this point. This point, what y value is it? Oh, look, it's 4. That 4 is the new x input. The new x input. So x equals 4. And I need to go towards g. And this time it's going to be down. So this point here is -3. So the answer is -3. Right. X goes in, does some calculation. Oh, that's the new x. Goes to the next, is the input to the next graph. And then the final output. Okay, you might want to watch that a couple times as well. So here, let's do the next one. Feel free to pause the video. X is equal to 4. X is equal to 4. I want to go towards G. That's the green one. So I'm going to go down. X equals 4 hits G here. That has a Y value of -3. -3 is the new input. So X equals -3. That's the new input. Now, which graph do we go towards? We care about H. So this one's going to go down. And that output is -2. -2. Speaking of -2, we have x equals -2. That's where we're going to start out, at x equals -2. So x equals -2 is here. We want to go towards h. So I'm going to go down. Hit h at this point. That y value is -4. -4 is the new input. -4 is the new input. We're going towards f. So I got to go up through G, like that. Pretend like G's not even there at this point. And whatever this f is, right here. So this looks like 5. I'll go with 5. That one's tricky because it's not on the map. Or it's not on the graph, rather. And, all right. We're almost there. 28. So 28, 29, 30. Oh my goodness, these are all the same. Oh, we still have 31, 32. Okay, we're almost there. 28. Find the composition of f of g of x, given f of x and g of x. Okay. So we can color code these again. F is in red. G is in blue. If you want to pick different colors, you can. All right. So g of x is the input into f. G of x is the input into f. So f is 8x plus 5. 8x plus 5. Notice, wherever there's an x, I always leave a gap. That's just my little technique. Oh my goodness. All right. So 8x plus 5. X is actually g of x, which in this case is 4x. So calculating, we're going to distribute, or it's multiplying. So this is going to be 32x plus 5. Hey, that's it. There's nothing else to do. 32x plus 5. Don't make a rookie mistake. Don't distribute a second time. It don't work that way. It only goes into the parentheses once. Okay. Keeping it going. Look what's dope about this. X is 3. X is 3. So here in 28, X was just X. So now X is a number, which is nice, believe me. Because we take 3 and we plug it into G. So G, in this case, so G of 3 is going to be 4 times 3, right? Because 4x, since X is 3. So this is going to be 4 times 3 is 12. 12 is the new input. 12 is the new input. So I got to take 12 and plug that into F. So this is how you'll see it. We're evaluating F at 12. So 8 times 12 plus 5. Right? Because 8x plus 5, x is 12, the input. So 8 times 12. 12, 24, 36, 48, 60, 72, 84, 96. 96 plus 5. Hey, 101. 101. Hopefully you can follow that and you can do good on the next one. Here G or X is going to be 4. X is going to be 4. That's my input into G. So G is 4x plus 1. So 4 times 4 plus 1. Right? That's what is G when you plug in 4. 4 times 4 is 16, plus 1 is 17. Now, 17 is my new input. Where's it going? It's going inside of F. So F of 17, because that's the input. This is going to be 2 times 17 minus 7. So 2 times 17, 34, minus 7, which is, so 4 and 3, right? So 30 minus 3, 27. 27. All right, we're almost there. Last two. All right, fine. 31. F of G of 16. So 16 is the X. So I want to go into G first. So I want to go to G, and X is 16. So when I go to G and X is 16, what's the output? The output is 4. Right? 4 is the new input into F. So I go to F, I go to input 4, right? Because X is the input, and we output 1. So 1 is the answer. C. C. I'm gonna erase this and reset. All right, last question. Here we are. X is equal to 4. Should have color coded it so you could see it better. X is equal to 4. So X into F. So input is 4. Output is 1. So output is 1. The output, that's the new input. Where's it going into? Going into G. So I'm taking 1, and then the output, oh, look, is 1 also. So D is 1. All right, I know it's kind of lengthy, but hopefully this helps someone. And have a good day. Good luck.